elevator pit pumps. It's something that keeps popping up, seems to be a lot of questions about them, and I want to make sure you kind of understand. The purpose of this, and a lot of people joke about them, is why would you have an elevator pit pump? Well, first of all, about all elevator pits now do have sprinklers on them. So there's water, in case of a fire, water's going to be sprayed in the elevator. Some of these elevators also have hydraulic oil in them to make sure they pump the elevators up and down. So you've got leakage potential there. And it's a low point in a building. Most elevator pits are going to be fairly low, so if you have a leak or any kind of thing else, you're going to collect water there. So those are the reasons you got elevator pit pump. So questions are, where do you put the fluid? Notice if you're pumping oil or water out of an elevator pit, where are you going to put it? Obviously, you can't dump that oil down the drain, or they'll get you. It was that hydraulic oil you cannot put down the sewage. You're going to have to break it off and contain it, separate it out, hold it, and dispose of it another way. So if you got a hydraulic type of an elevator, you better recommend some kind of way to test and see if you've got oil, hydraulic oil leaking, because by code, you cannot put it down the sewage, and if you do, so it could be a pretty serious fine. You just don't want to do that. So let's look a little bit further at elevator pit pumps. And these have been confusing to people because there's so many different versions of this, so many codes out there, and it's been pretty much a local plumbing inspector's guideline. But things are changing a little bit because we're finding this showing up in the elevator specifications and elevator codes, not so much the plumbing code. But again, I warn you, talk to your local plumbing inspectors, talk to your local plumbing authorities, wherever your project is, bring up the word elevator pit pump and ask them what they want. Please, please listen to me. That's the way to get there. Otherwise, you're just guessing. You don't know what. What on a national basis are we seeing? I show you this from the North Carolina elevator code, and this elevator code is in Texas, it's in South Carolina, it's pretty much everywhere now. I can't tell you it's going to be where you are, but this is pretty much the national elevator code that's out there, subject to what the local plumbing inspector wants to do. And guess what? It says 50 GPM per elevator. Yes, 50 GPM, 3,000 gallons per hour per elevator. Anywhere a firefighter can control an elevator, has individual control, you shall have an elevator pit pump per elevator of 50 GPM or 3,000 gallons per hour. We recently did a job. They had 6 elevators in one common shaft, 6. The elevator pit pump, correct, was 300 gallons a minute, 300 GPM for elevator pit pump. That's the law. Sometimes people tease about all that, but stop and think. You got firemen in there, you got sprinklers in there. You don't want a bunch of water building up in there causing problems. So the code pretty much is clear now. This is what everybody's basically doing, subject to the local plumbing guy. But if you don't have anything else to go on, I would assume that you follow this code at 50 GPM per elevator that can be controlled by the farmer. And if you look at that in North Carolina, for example, normally 15, 20 feet ahead to take care of the problem at 50 GPM, and you come up with a pump for that. And for the record, there's another Valangosset pump that we picked, 450 GPM, actually 21 feet ahead. But we did put one of these oil sensor smart switches on there. You probably need to be aware of this. We see most designers including these now. And also the National Electric Code has a little comment about how you do ground fault. You've got to make sure you got ground faults on these. Pretty basic. You probably don't need to worry about it. It's kind of a latest edition, but they're saying specifically elevators shall have the ground fault circuit protection on these pumps. Here's a typical little pump curve, and basically you see we got a pump picked at 50 GPM at 20 feet ahead. And here's this oil smart stuff. All we're saying is you need to specify something that can sense the fact that there's hydraulic oil in these pits. You can't pump it down the drain. You're going to have to pump it someplace else or cut the pump off and sound an alarm. Those are the choices you have, but you cannot allow these pumps to pump oil down the drain. You're going to be in trouble. And like I said, most specifications are putting these oil smart pump switches in place now, little various ways of doing it with an alarm. So if you've got that situation, sit down and talk to your engineer, look at your application, recommend these. We got them readily available, actually in inventory for you. Ladies and gentlemen, we've had fun. We've cut a lot of territory. We covered basic sump pumps and basic elevator pit pumps, and we kind of caught you up to date on some codes. I believe you have enough tools in your toolbox now to go out and pick these things, make sure they run fine. If you'll keep in mind the rules of thumbs we gave you, you can do anything you want. But if you'll follow the guidelines we gave you, and you'll make sure you show the float locations, you're going to have a trouble-free system that's going to run forever without you having to go down into that sump. And I think that's pretty daggone important. Maintenance-wise, you could get some clogging on these. You really don't want it, but that's why you got the chair rails to get them up. If you don't do it properly, if you don't let them run a minute and a half, you're going to short cycle. You're going to have heat build up. You're going to tear them up. Improper float position, not locating the float properly when you go to start it, is the biggest problem we've got. We got to make sure the pump stays submerged, so when everything cuts off, liquid level's got to be enough to keep the pump flooded. And we got to make sure we don't overload the motors due to oversizing the pump. What does that mean? We said to you, you can't balance these pumps. So do a detailed pump head loss calculation and make sure you get only the head required. Because if you overhead the pump and it runs off to the right of the pump curve, you're going to overload the motor, overamp it, and you cannot throttle. No way. Therefore, you got to do that. Do those quick things. I think you'll be happy. Have a great day. It's been fun working with you.